Well, hello, this is Craig Hane, and this is my website at craighane.com. And we're going to have now a discussion of workshop number 4. Now, workshop number 4 is designed to discuss mathematics that the college-bound STEM student needs to know. Now, STEM stands for Science, Technology, Engineering, and Mathematics. And this will really focus particularly on the first three, science, technology, and engineering. And I'll have a little bit to say more about the mathematics major in a moment. Now, I have to say this is a very complicated subject, and it probably has some very surprising answers for you. And in order to understand it, you must understand the modern standard math curriculum, and in particular its deficiencies. And then what I want to do in this workshop is to arm you with some tools that will ensure your students' success at the college level if they want to be a STEM type student. I'm going to give you an example of this, and I'm going to talk about how you can prepare your student to compete with international students, because today, as you probably know, a high percentage of graduate students in the STEM subjects are non-U.S. students, international students, and a fairly significant percentage are at the undergraduate level as well. And there's reasons for that I'll be talking about in a moment. And in order to understand this, we're going to be discussing the first tiers 4 through 6 of my 10-tier program. Now, to fully understand everything I'm going to tell you, I would highly recommend that you get a copy of my book, Teaching Math, and read it. And in particular, I would like to focus your attention on Chapters 3, the power tools of mathematics, and Chapter 5, a modern 21st century math curriculum. These are the two chapters that you really need to understand to fully understand what the problem is today. And of course, I've already discussed in previous workshops the deficiency of the high school math ed delivery system, because really it can't follow the essentials of good math education because of the way it's done in the batch mode, the classroom mode. But chapters 3 and chapters 5 are what I would particularly want you to pay attention to understand this problem. Now, I start off chapter 3 by pointing out that there are 4 power tools that make both the learning and the practice of mathematics quite amazing in this 21st century. And the failure to utilize these 4 power tools appropriately will greatly impede the learning of mathematics and the practice. And in fact, what will happen is it will render our children really second-class citizens in the whole new world we live in. As a matter of fact, I'm always amused by the no child left behind concept of our current education system. Actually, I would rather think that in the case of mathematics, particularly for STEM students, it's more like every child is left behind. All right, the first power tool that I talk about is the scientific calculator. And of course, you've heard me talk all about that with the Practical Math Foundation, and we also use it in Tier 3. And this remarkable instrument actually has just revolutionized how we teach and practice mathematics, particularly doing all the arithmetic calculations. When I compare it to the way we had to teach mathematics prior to the scientific calculator, it's truly amazing. 95% of the work and effort and things that we had to learn back pre-calculator days are now obsolete because the calculator does them for us. And if you've been through our Practical Math Foundation course, you fully understand why that is the case. And you just can't even imagine how long it would take to do that if you didn't have this tool of the calculator. Now, about 10 years after the calculator came along, we got the first spreadsheet, and of course they now have evolved dramatically. And today, the electronic spreadsheet, of course, totally revolutionizes the way you do a great deal of mathematics. As a matter of fact, I consider the graphing calculators really just a waste of time, almost a joke. If you're going to do graphing, you want to use a more modern tool, and it depends on what you're doing, but spreadsheets are an extremely powerful tool, and I can't even imagine doing modern math today without spreadsheets. And then there's special applications. A spreadsheet is actually kind of like a programming language. For example, if you want to learn statistics or statistical process control, there is a wonderful spreadsheet application called SPC for Excel that I would use to teach statistics to anybody. And indeed, I've done this for industrial people. And that's a great way to learn statistics so much faster than the old manual ways. I might add that the standard curriculum today that is taught in most high school courses and books have not really taken advantage of either the calculator or the spreadsheet the way they can to not only make the teaching and the learning of the subject much easier, but to make it much more powerful. But then, as I point out in my book, the best was really yet to come. There is a fantastic tool that was developed in the late 80s that's called Mathematica. Now, the truth of the matter is this just totally revolutionizes the way you do modern math, particularly when you get to calculus and differential equations, which of course are mandatory nowadays for STEM students, and they should learn these things in high school. And so Mathematica is something that I highly recommend students learn, and we begin to learn to use it in Tier 4, and then we really use it heavily in Tiers 5 and 6, which I'll be talking more about in a moment. And the really good news is that in 2009, a free version of Mathematica became available on the internet called Wolfram Alpha. Now, if you've never played with Wolfram Alpha, you need to go take a look at it. It is just an absolutely remarkable tool, and it truly revolutionizes the way we solve calculus problems and differential equation problems and all sorts of problems that are traditionally taught. And so you must absolutely take advantage of these power tools, and that's the first great deficiency in our standard math curriculum today is failure to take full advantage of these power tools in both the teaching and the practice of mathematics. Well, okay, so now what should we do? Well, the answer is for students that are going to go into a STEM subject, you want to next put them into Tier 4, which is going to be their third pass now through algebra and geometry and trigonometry. And what I'm going to do in that Tier 4 is we're going to take Dr. Simmons' book and actually go through now the entire book. Everything that was not yet done in Tier 3 now will be covered in Tier 4. In particular, we'll be discussing trigonometry, and he has a very excellent treatment of that. And we'll be going back through the geometry again because we not only want to review what we learned, but we want to learn a lot of new things that would be very useful for a STEM major. And so we go through Simmons' book this time. The first time through we only did maybe 40% of it, 30% of it, and now we'll do everything else. And so we'll do that as part of Tier 4. But in addition to Tier 4, I do something that is never done today, to my knowledge, at least not in a proper way in high school that needs to be, and that is we treat the complex numbers a special way. Now, if you don't know mathematics, this won't mean much to you, but if you do, then you'll know there's something called complex numbers, and it turns out they are extremely important in science and engineering, and I call this the gaping hole in our current standard math curriculum. Students that graduate from United States public school systems and go off to a school like MIT or any good engineering school or science school are at a huge disadvantage right away from their international competitors because they haven't even been exposed to complex numbers, much less how to understand them. Now, what I do to help remedy this situation, make sure you understand it, if you go to the CraigHane.com website, and here at the CraigHane.com website, if you go down to the 6th tab down, it says for advanced students or math teachers, and click on that. The first thing you're going to get is you're going to get a rather long video. This is about 40 minutes long about complex numbers. And I'm going to explain to you in this video the way complex numbers ought to be taught to your students, assuming you already know a lot about it. If you don't know anything about it, then this won't mean much to you. You'll find it difficult to understand. But if you're a teacher and you're interested in doing it, then this will tell you how to do it. And then I have a bunch of additional videos which you can access by opting in and giving us your name. We want to start talking to you. But I have 3 on calculus, an introduction to calculus, an overview, then a video on differential calculus, and a video on integral calculus. Now, calculus, of course, is the basis of science and engineering. It's what you take right after so-called pre-calculus mathematics, and it was developed back in the late 1600s and 1700s and applies to modern science and is extremely important. Then there's a lot of other topics that you'll want to be exposed to and know something about. Talk about the concept of infinity. I have a video on that. We talk about rational and irrational numbers and when they're important, when they're not important. Different number systems, numbers for non-mathematicians, numbers for mathematicians. And these are all videos that would be of interest to you if you want to know how to teach the STEM students. Now, what we do after Tier 4, which is the third pass through algebra, geometry, and trig at a very, very thorough and deep level, and including the treatment of complex numbers and the way it ought to be done. And by the way, you'll never really understand trigonometry as well as you need to understand it until you understand complex numbers. Trigonometry, by the way, is a very important subject and a very deep subject when you get to using it at the STEM level. Now, in Tier 5, we do calculus. And if you study my 3 videos I mentioned to you, you'll understand what we cover in it. And it turns out you can learn all the calculus that you need for modern science and engineering with the modern tools, thankfully, in probably about 3 months. And then in Tier 6, we do differential equations. These are the workhorse of science and engineering. And if you understand them, then you're going to be much better prepared to go to one of these schools. Now, the facts are, when your international competitors, the students that are trained in really top-notch schools or by good tutors, come there, they're going to know these things. And if your students don't know them, then they're going to be at a disadvantage. And that's just simply not fair to them. And it's one reason I believe that many of our U.S. students are not going into the STEM subjects. They simply can't meet the competition. They get there, they don't do well. I believe that a very high percentage of our students would go into STEM subject very successfully if they had the training that I'm advocating here in mathematics. And now the question is, what about so-called math students, people that might want to major in mathematics? Well, I suggest you go right to Chapter 10 and Chapter 11 and read those, because that really discusses what we need to do for future mathematicians, and we're not even coming close today at high school level doing it. Some of our international competitors are. There might be some private schools or students with private tutors are getting this, but certainly not students in our regular school system. And this is a great tragedy for those students that might have the potential to become mathematicians. And so I would urge you to read Chapters 10 and 11. Now, if you don't know mathematics, it won't mean much to you, but you can take my word for it. It's what our students will need to be learning if they're going to be competitive and really reach their objectives as mathematicians. So now the question is, where do we go from here? Well, I have a lot of information on the site. I have a case study of a nice big homeschool group that's doing very well with Tier 2 and 1 and 3. Now right above that I have my Vita, which if you want to know who I am and what my background is, it gives me a right to have these opinions or where they're coming from. You should read that. There's a couple of videos on it. It's a rather long Vita. I have a discussion for practical math for industry. I've got a message to high school principals and indeed a radical solution for them if they would be willing to do it. I'm not optimistic, frankly. We've talked about some of these other tabs here. Actually, the best way for you to get started today is to enroll your student or yourself in the Practical Math Foundation course and really get going learning math. And once you've gone through that, you can then decide how much further you want to go and what direction you want to go. And as you can see, with a tiered approach, really sky's the limit, and you can go as far as you want to go. And I hope that you learn the math that is appropriate for you, and you have as much success with it and satisfaction from it as I've had. So once again, I invite you to email me or call me, and I'll be glad to send you a PDF copy of my teaching math book. and engage in a discussion on the teaching of mathematics if you are so interested. Dr. Dell, I wish you the best.